Hello there, Mr. Wilson here again for what is probably the final part of these revision lessons about matrices. Now, just before we get started, two things. If you haven't already, definitely subscribe to the channel because there are loads and loads of videos. One every single day is being uploaded to the channel, and there'll be loads more content coming out in the future. And secondly, this whole topic was requested by someone in the comments. So if there's a particular topic you would like me to cover, then please let me know, and it'll give me some inspiration to have a go at this topic. But this was from a commenter who wanted some a recap on matrices for GCSE further maths. So if there is a topic for GCSE maths, further maths, or A-level maths, then let me know and I can do that. But in this part, we're going to look at combined matrix transformations and exam, if we move out of the way, questions, exam cues. So we're going to have a look at those and see what we can come up with. Just as a little recap then, let's have a look at these exam questions to see if we can recap what we did last time on matrix transformation. So it says, describe fully the single transformation represented by 0, 1, negative 1, 0. Well, a way to test a matrix is to multiply it by the coordinate xy and see what happens, right? So 0 times x is 0, 1 times y is y, and then 1 times negative 1 times x is negative 1, negative x, 0 times y is 0, so this is going to be negative x. So in other words, if you do this transformation, you are going to basically flip the coordinate over, and then what is now the y coordinate but used to be the x coordinate is now negative. Okay, so that's quite an interesting idea. So think back to our unit square then. The x coordinate, the y coordinate change, so basically it's on the other side, but now the y coordinate is negative. What is now the y coordinate but used to be the x coordinate is now negative. So I'll just give you a quick pause to just have a think about what transformation that is going to be, and if you have your flashcards you might know what transformation this is. Now I believe this transformation is a rotation 90 degrees clockwise about the origin. Okay, because when you rotate something 90 degrees clockwise, the x coordinates now become the y coordinates but negative, and the y coordinates become the x coordinates but not negative. They stay as they are. Describe fully the single transformation represented by 5005. Well, if you multiply it by a coordinate xy, you're going to get 5 times x is 5x, 0 times y is 0, and then 0 times x is 0, 5 times y is 5y. So you get 5x, 5y. In other words, all the coordinates get multiplied by 5. So this, if all the coordinates are going to get multiplied by 5, that is just an enlargement by scale factor 5, centre 0, 0. It's really important we mention that it's about the origin or about 0, 0 centre for all of these transformations, because when you get to a high level in maths, you realise that obviously if it's not going to start at 0, 0, then there's going to be a different matrix which is going to give that sort of outcome. But yeah, centred 0, 0 is just 5005. And as we discussed, this is just k times the identity matrix, where k is the scale factor in this case. So when we combine transformations then, suppose that we have a point L and we want to apply one transformation to it, right, call it T1, that's some matrix, and then we apply another transformation, T2. This can be represented below. So we take the point L, we do a transformation to it, we get some point, and then we do another transformation, we get a final point. So basically what we're asking is, what is the transformation then that takes us from the first one to the last one? A single transformation that goes from the first to the last point without having to do sort of two steps. Now when we perform two transformations on a shape, we can carry this out with one matrix followed by another matrix, and we can combine the two matrices together into one. The only catch is that the second transformation matrix goes first. Right, so let me explain with an example. So let's say I have this example here. A shape is transformed using the matrix A. Right, so let's say A is 1, 0, 0, minus 1. Now some of you might know what the transformation for that is. And then by the matrix B, which is 3, 0, 0, 3. And again, some of you might know what that transformation is. If you're already switched on to what these transformations are. So basically, I'm going to take a shape, I'm going to do matrix A, and then matrix B. However, when you do, so you have some shape, and you perform matrix A, and then you perform matrix B, and you get the image. When you actually multiply the matrices, you have to do them in the reverse order. Bit weird, I know. So you are actually going to do B times A, as what I've put down here. So you're going to, the combined matrix would be B times A. So we put B first, right, which is 3, 0, 0, 3, then A, because A is going first. Basically, the reason why you have to do it this way around is, if you imagine a coordinate on this end, right, some coordinate xy on this end of the whole thing, well, this coordinate is going to interact with this matrix first, isn't it? Because they're next to each other. When you multiply them together, they have to be next to each other. So these two are going to interact first, then it's going to interact with this one. So actually it makes sense to do it in this order, where A goes on the right and then B goes on the left, because actually these two are touching each other, they're going to interact first, then it's going to interact with this. So actually it does make sense when you think about it, but initially it doesn't make much sense at all. So we have to write it this way around, and then you just do your normal matrix multiplication to work out what the combined matrix is. So 3 times 1, which is 3, 0 times 0, which is still 3, so the top number is going to be 3. And then 3 times 0, 0, 0 times -1 is 0, so this top right one's going to be 0. 0 times 1 is 0, 3 times 0 is also 0, so this bottom left one's going to be 0. And 0 times 0 is 0, 3 times -1 is -3. So we get this. So that would be the combined matrix transformation for that matrix followed by that matrix. So it would be A in this case. Hopefully that makes some kind of sense. So let's have a look at this exam style question then. So the transformation matrix -1, 0, 0, -1, again, some of you might know what that transformation is, maps point P onto Q. The matrix, transformation matrix 0, 1, 1, 0 maps Q to R. The point P is 4, -1. Work out the coordinates of R. So basically, remember, when we are doing, so P to Q, Q to R, and this is the point P. So remember, it goes, this one goes on the right because that's the first matrix, and this one goes on the left. So that's going to be the first matrix we write down, 0, 1, 1, 0, because that one has to go on the left because it's the second one. I know, remember, reverse order, it's counterintuitive. Then the matrix, then our coordinate will go after. Now, if you combine these matrices together, so you do the matrix transformation, this is the first one. This is the first one, let's call this A. This is the first one, let's call this B. And this is the combined matrix BA. So then if I want to work out the coordinates of R, I just do my combined matrix, which is the combination of these two, times my coordinate. And we spent loads of practice last time on a matrix times a coordinate. So we just get 0 times 4, which is 0, plus 1 times -1 times -1, which is 1. And then -1 times 4 is -4, and that's going to be 0, so that's -4. So basically the x and y coordinates flip over, and it keeps being negative on that one, but reverse for the other one. It's very strange. But that's the transformation. It just asks for the coordinate. It doesn't ask for what transformation is this. It just asks for the coordinate of R. So what I want you to have a go at then is I want you to pause this video and have a go at this question here. So write down the matrix A, which represents a rotation 90 degrees clockwise about the origin. Write down matrix B, which represents a reflection in the line y equals x. Find the matrix for which represents the transformation A followed by B, and describe this transformation. So I'll give you a moment just to have a go at this. And again, if you are struggling to remember these, I would look back at the previous video towards the end I show like a bit of a cheat sheet with all the different matrix transformations for GCSE further maths. So I would definitely get that up if you are struggling to remember these. But pause the video now, give this question a go, and then we'll discuss it in a bit. Okay then, so this first part then, write down the matrix A, which represents a rotation 90 degrees clockwise about the origin. Well, that's going to be 0, 1, negative 1, 0. Right? That's just what it is. You could either remember it or you could do the method that I did last time and try and work it out. Matrix B, the reflection in y equals x, well, the x and y coordinates flip over basically. So it's 0, minus 1, minus 1, 0. Is that right for this one? Or that would be... Would that be for... You can tell with my confused face that this is not right. Clearly this exam question is not very good because this should be... See, that's why I was confused. 0, 1, 1, 0 for the line y equals x. Write down the combination matrix. So basically you want to do A on the right, B on the left. So 0, 1, negative 1, 0 and 0, 1, 1, 0. Multiply them together so we get 0 plus 1, which is going to give me 1. And then we need to do, that's going to be 0, and this is going to be 0, and this is going to be, so it's going to be 1 times 0, 0 times negative 1, so that's going to be 0. 1 times 1 is 1, 0 times 0 is 1. So you get 1, 0, 0, 1. Is that what they've put for, see, no, that's not what they've put for this, because they've got the wrong... transformation for the line y equals x. So basically, if you do a rotation 90 degrees clockwise, so you imagine a shape like this, you rotate it 90 degrees clockwise, so it's going to appear here, and then you reflect it in the line, have I made a mistake here with the multiplication? My gut instinct tells me yes. Oh, it should be a negative, that's why I'm getting confused. A negative there, see? Oh, well, I'll spot the mistake then. Because otherwise it would have been the identity matrix, and it's definitely not the same for what it was. So you get this. So basically you've rotated it 90, and then you've reflected it in the line y equals x, so it now appears in the top left quadrant. In other words, this, you might actually also notice from your flashcards, is a reflection in the y-axis. Who would have thought it? So this is actually a reflection of the y-axis. So a rotation 90 degrees clockwise and a reflection in the line y equals x gives a reflection in the y-axis as one transformation. So when they say describe this transformation, the combined transformation, sometimes it's actually a different transformation that you already know from your revision flashcards. 1001 minus 1001 is a reflection in the y-axis. Let's see if this exam question actually gets it right. So the transformation matrix negative 1, 0, 0, 1 maps the point P. Oh no, I think we've done something similar to that, haven't we? Yeah, we've done these ones. I want to do one where it's yeah, something like this. So here are two transformations. A rotation of 180 degrees about the origin, I assume, and then a reflection in the x-axis. Work out the single matrix which represents the combined transformation A followed by B. Okay, I'll give you a few moments to have a think through this one, and then we'll go through the answers. And if it's not right, I will put on my confused face, and then I'll correct it. So a rotation of 180 degrees then is minus 1, 0, 0, minus 1. I agree with that, definitely, because the x and y coordinates both go negative. It appears on the opposite side of whatever quadrant it was on. A reflection in the x-axis is 1, 0, 0, minus 1. And then their combined matrix would be minus 1, 0, 0, 1. Now, you might notice that minus 1, 0, 0, 0, minus 1, 0, 0, 1, I got there eventually, looks like something that we've already seen before, because basically all the x coordinates go to being negative, but the y coordinates stay the same. So in other words, it's the y coordinates are staying the same, but they've gone to be negative. This is actually a reflection in the y-axis. And if we flick back to our previous question, -1001 is a reflection of the x-axis. It just so happens that a rotation 180 degrees and a reflection in the x-axis is the same as a reflection in the y-axis. So you find these sort of subtle ideas where actually combined matrices can give the same as one that we already know, or the one that we already should know. So what I'm going to do then is I'm actually going to leave it there for this part, because I think that's really encapsulate combined matrix transformations. And we looked at some exam style questions, some of which were wrong, so we corrected them, didn't we? But a lot of this stuff we just need to remember. I mean, you can work it out, but again, like I said in the previous video, we should have some idea before we walk into that exam hall about what kind of transformations are what, and it'll save us a bit of time. Just to sort of wrap up this video then, let's just talk about some exam techniques for this topic. I mean, first of all, I've talked in the previous video about revision cards and writing down those transformations on revision cards and constantly reminding yourself about the transformations and what they are and what numbers are in what positions, because a lot of them, especially the sort of beginner transformations that you do in GCSE further maths, are very similar, like really similar. There's a lot of ones, minus ones in there, zeros, all very similar to each other, but all do completely different transformations. So that would be my first tip. Obviously, in an exam, people can misremember things. You know, I thinking back to when I did my exam, you know, you feel like your brain is just clouded with all these ideas, and you can't really fish out the correct one. You know what I mean? Because there's so many different things going through your head. Like when I try and remember exact trig values, a similar thing happens where you know there's one of them's equal to a half, or one of them's equal to √3/2, or one of them's equal to a third, and all this, that, and the other, or 1/√3, and all this, but you kind of can't match up which one is which because your sort of judgment is a little bit clouded up. So I would recommend, obviously try and remember what you can, but I would recommend that in the exam, just double check. So when I did the questions in the last session where I multiplied by a coordinate, and then I double checked that this was this, these two times together, it does equal this. Just a little check like that can really save a lot of missed marks through misremembering a transformation, because you might think, oh yeah, it's 0, 1, 1, 0, when in actual fact it was 0, -1, -1, 0, and you've got something completely different and a completely different answer. It doesn't work anymore. So misremembering is a very common mistake. I think the main thing about matrices is that because it is so new to a lot of students, it can be quite scary. I think the biggest challenge in matrices is this mental block that students have, which says, I can't do this, it's too complicated. And realistically, when you look back on it, when you study more in maths and you look back on maths that you learn in sort of year 7, 8, 9, 10, 11, you think, yeah, it wasn't actually that bad. Especially when you go on to do an A-level or a degree. And that's not to be like big-headed, but it's sort of like it gives you a bit more perspective on actually, like, you know what, when you sort of try and practice, it sinks in eventually, and it sort of makes sense. And sometimes this can take one lesson, could take 2 lessons. I had it one time where I was doing A-level further maths, and there's a topic called de Moivre's theorem, and some of you in the comments might say that de Moivre's theorem, oh, I know what that is, but for some reason, college age me could not understand how it worked, even though it's a theorem and it's like a formula and you apply it to complex numbers, I believe, from what I remember. I couldn't understand how to use it or when to use it, or what type of questions it's used in, or how it works, or anything to do with it. It just was a total barrier for me. And I remember all my classmates around me when we were in college, they were getting it, and I was just like, I do not understand what this is, and I felt like a bit of an idiot, really. But just because you don't understand one thing in maths, or two things, or three things, does not mean you are bad at maths, right? I, that was one occasion, and there were several others where I think it took me 6, 7, 8 months to really get it to sink in. And even by the time I got to the exam, I wasn't fully confident in that particular topic. I was sort of hoping it didn't come from the exam. But it's one of those things where just because you're not maybe as good as some things in maths or GCSE further maths, that doesn't make you a bad mathematician at all. And I think a lot of students can panic quite a bit when they don't understand one thing. They think they're just terrible at maths, and that's not true. Just because you don't understand one thing and you don't understand it right away doesn't mean you'll never understand it. It might the penny might drop literally the day before the exam. Who knows? But it's maths takes patience, and I think I have learnt that over many years of studying it. I think one thing I've learned about studying maths is you have to kind of respect it a little bit. Maths is really challenging. And when you study it at university, that is not even the highest level of maths, and yet it is so difficult and so challenging and so mentally straining. You have to give it the respect it deserves, because it's just such an amazing world out there to discover of maths, and you have to give it the time and the patience that maths requires to understand this sort of amazing world. And this is just one part of it. Matrices, this sort of stuff, matrix transformations, multiply matrices, is just the first sort of few rungs on a whole scale of maths, because matrices links to something called group theory, because you can have a group of matrices and you can go down that sort of route in terms of maths, or you could do more complex matrix. You could go down the route of sort of computer science, where they use matrices in computer science, things like that. So this is just the very start of this whole amazing world, and by learning this, you've actually already tapped into that amazing world of maths and stuff that is a little bit more out there than the stuff you normally do at GCSE. So I just want to say well done to anybody who takes on GCSE further maths. I mean, it is not easy, and you deserve all the credit that people give you, because people who say, oh, it's just more maths, are lying, because it's not. It's more maths, but more challenging maths, new concepts, new ideas, and stuff that's going to allow you to have a little edge up when you maybe go and study an A-level in maths, or A-level further maths, or even an A-level in science. A lot of the skills like differentiation and things like that are very useful for, and just algebra skills are just very useful for science as well. Anyway, I feel like I've ranted enough about sort of boosting people's confidence a little bit. But yeah, I just want to say that thank you so much for watching to the end of this video. If you've enjoyed that little motivational speech, then let me know in the comments below, because it's important that we keep everybody motivated on maths. Everyone's on their own path and their own journey, and everyone needs to support each other in maths. So if you're studying with somebody and you know that you get a topic and they don't, go and help them. Why not? You know what I mean? That's what we're all about in maths. We're all about helping each other out. So that is the end of the video, I promise. All I want to say is, if you haven't already, definitely subscribe. If you've made it this far in the video, you must be an absolute trooper, and you must be one that is definitely up for subscribing, because if you've lasted this long, then of me ranting about maths, then you should definitely subscribe. There are loads more videos on the channel. At the time of recording this, close to 250 videos, I think, on the channel about GCSE maths, further maths and A-level maths. And if there's anything you would like me to cover, please let me know in the comments below. But I think this will be the last part of these matrices. I will try and do more of these revision lessons on other topics, as and when people request different topics and as and when they come up. But for now, all I want to say is thank you so much for watching, and hope you have a fantastic day.